For as long as we have looked up, one celestial body has dominated our sky. It is the giver of life, the keeper of time, the star of our every morning. We call it the sun. It warms our faces, grows our food, and paints our world with light. It feels so familiar, so constant, that we can almost take it for granted. But this star, our star, holds deep and profound mysteries. It is a place of unimaginable power and fury, a churning, boiling giant of plasma so vast that 1,000,000 Earths could fit inside it. And for all our centuries of observation, we have only ever seen it from a great distance. We've been standing on the shore, gazing out at a mighty ocean, unable to know what truly happens within its depths. We've always been drawn to its light, compelled by a fundamental human need to understand. What fuels this magnificent engine? What causes the violent eruptions that we see from 93 million miles away? These are not just questions of idle curiosity. The sun's behavior directly affects our world. Its moods can disrupt our satellites, interfere with our power grids, and even pose a risk to astronauts in space. To understand the sun is to understand a critical piece of our own survival. It is to learn the language of the cosmos, spoken by the most powerful object in our solar system. The desire to know more, to get closer, became an obsession for generations of scientists. This journey of understanding is a long and patient one. It began with ancient peoples who tracked the sun's path to mark the seasons. It continued with Galileo, who risked everything to point his telescope at its face and map its strange dark spots. Each discovery only brought more questions. Each new piece of the puzzle revealed how much more of the picture was missing. We learned about its immense gravity, its searing heat, and the solar wind it constantly breathes out into space. But the very heart of the storm, the corona, the sun's atmosphere, remained a profound enigma. How could this outer layer be hundreds of times hotter than the surface below it? It was a paradox that defied our understanding of physics. So we decided to do something bold, something that was once the stuff of science fiction. We decided to go there. Not with our own bodies, of course, for no human could survive such a journey. But we could send a proxy, a messenger, a brave little machine designed to withstand the fires of creation and report back what it saw. We would build a probe, a shield, and a set of instruments, and send them on a mission to touch the sun. It was a plan born of immense ambition, driven by our unending quest to pull back the curtain on the universe and see the face of our very own star. And so, NASA created the Parker Solar Probe. Think of it as our first emissary to the sun, a marvel of human ingenuity no bigger than a small car. Its mission was simple to state, but incredibly difficult to achieve: to fly directly through the sun's atmosphere, the corona. The data began to trickle back across the vastness of space. A stream of numbers and readings transmitted from the heart of the solar system. For a long time, this is all it was. Measurements of particles, readings of magnetic fields. It was invaluable information, and it was already beginning to reshape our theories. But the most anticipated data was still to come. The images, the pictures captured by the Wide Field Imager for Solar Probe, or WISPAR. This instrument was designed to take pictures of the faint structures within the sun's corona and the solar wind. It was our window into this alien environment. The first images were breathtaking. They showed a universe alive with movement. For the first time, we could see the solar wind not as an abstract concept, but as a tangible, flowing substance. We saw streamers and rays of plasma, the sun's own atmosphere stretching out into space. It was like looking at a cosmic river, with currents and eddies swirling around the probe. But as the probe ventured closer on its later orbits, the images began to reveal something else, something hidden within the larger, brighter streamers. At first they were faint, almost like artifacts in the data or smudges on the camera lens. They were subtle, fine lines and delicate, crisscrossing patterns that seemed to be embedded within the solar wind itself. These were structures that none of our models had predicted. They were too small and too intricate to be seen from Earth. They were a complete surprise. The scientists were puzzled. What were they looking at? Was this the secret they had been both seeking and dreading? The suspense grew with each new data download. The team worked tirelessly to process the images, to enhance them, and to make sense of these ghostly apparitions. They were not random. They had a distinct geometry, a shape that suggested they were not just random fluctuations. They looked almost organized, like a network or a web. The shocking discovery was not a single, terrifying event. It was really more like the slow, dawning realization of what these faint lines in the images actually represented. As the Parker probe flew closer to the Sun, it passed directly through these structures. Its other instruments, the ones measuring particles and magnetic fields, recorded what was happening. And honestly, the data was startling. These were not just passive lines. They were active, dynamic features. They were incredibly thin, concentrated jets of material, moving much faster than the surrounding solar wind. And they were everywhere. The probe was flying through a vast, intricate network of these jets. Scientists have a name for them now. They call them switchbacks. Imagine you are driving on a mountain road with a series of sharp hairpin turns. That is what these structures do to the Sun's magnetic field. But within these switchbacks, the magnetic field suddenly and violently reverses direction, like a whip cracking. The probe was flying through a cosmic minefield of these magnetic explosions. It was a level of complexity and violence in the solar wind that no one had ever anticipated. This was the source of the scientists' initial concern, realized in a way they hadn't imagined. They had feared finding instability, and here it was. Not as a single large threat, but as a fundamental built-in feature of the solar wind. The space between the planets was not a calm sea. It was a turbulent ocean, filled with these invisible magnetic traps. These switchbacks are like small, localized storms, each one a burst of accelerated particles and twisted magnetic energy. The probe's images revealed that the corona is not a smooth, uniform atmosphere. It is a tangled, messy, and surprisingly structured place. Because these switchbacks appear to be a key part of what heats the corona and accelerates the solar wind in the first place. They are not just a side effect, they may be the engine itself. This discovery completely changes our understanding of the Sun's influence on the solar system. It means that the solar wind is not just a steady breeze, but a gusty, chaotic gale filled with tiny, powerful jets. We were living in a storm without ever knowing it. The Parker Solar Probe is not finished. Its mission will continue for several more years. With each orbit, it will swing closer and closer to the Sun, venturing deeper into the corona than ever before. It will brave even more intense heat and radiation, and it will undoubtedly uncover even more secrets. The discovery of the switchbacks is likely just the beginning. What other hidden structures and processes are waiting for us in the Sun's fiery atmosphere? What else have we failed to imagine? The probe continues its silent vigil, our steadfast messenger in the heart of the solar system. This quest for knowledge is what defines us. From the first human who looked at the stars and wondered, to the teams of scientists guiding a probe through the Sun's fire, the journey is the same. It is a journey outward, into the cosmos. But it is also a journey inward, to understand ourselves and our place in it all. Every discovery, whether it is a new planet around a distant star or a new insight into our own Sun, adds another piece to that grand puzzle. It is a legacy that we build upon generation after generation. So the next time you feel the warmth of the Sun on your skin, take a moment. Think of that brave little probe flying through an invisible storm of magnetic explosions 93 million miles away. It is out there right now, expanding the boundaries of human knowledge on our behalf. And it invites us all to remain curious, to keep asking questions, and to never stop looking up. Please like and subscribe to Cosmic Discover.